big warm welcome to everyone. Thank you for joining. So as you know, today we will speak a bit about edge computing and basically what it is, what does it matter, how you guys can use it. I don't know if your background is somehow related to computer science. Anyway, we'll try to keep things as simple as possible as they should be. Try to demystify a bit something which is now becoming a bit trendy and very popular. So before we actually go a bit more in depth into edge computing, just a small introduction. Myself, I'm Cristovao Cordeiro. This is a Portuguese name, plenty of accents, so you can just call me Chris, it's much easier. I'm a technical project manager at SixSq and also a software architect. And mainly my work is involving European projects and coordination with other companies in Europe that attempt and try to make research and innovation towards cloud computing and edge computing. Therefore, ourselves at SixSq, we have quite a bit of experience with cloud and edge computing. And the message that we are trying to pass here today is not to try to impose a definition, but instead to simplify something which is actually quite old. And towards the end of the presentation, we'll even do a quick demo and show you in practice how you can manage a few applications in the cloud and at the edge. So if you remember just, well, not too long ago, the big thing was centralized computing. We had supercomputers, we had mainframes. And then with the capability of doing distributed computing, and when the internet was born, which was in '89, we had the capabilities to start doing grid computing. So this was something else. This was basically the ability to join together multiple clusters that are geographically distant from each other to form a larger one, a large scale cluster. And this concept started introducing heterogeneity. So different clusters would have different hardware, different operating systems, and so on. But still, the concept itself worked well and allowed users to share their resources throughout the world. Then later on, we started having the so-called cloud computing, which is still trending and still buzzing nowadays. And here, basically, we start introducing the concept of virtualization. So the point here is that users can simply use a sort of commodity as a service. There are companies that started providing cloud computing as a service. And the users that need an extra piece of computing or that want just to use the commodity of having all the networking, all the hardware and infrastructure set by these companies can just ask for resources, virtualized resources on demand. And some of them would even form hybrid clouds where you would have your local clusters joined together with cloud computing working as one. Then we started having mobile computing, of course. Smartphones started appearing everywhere and IoT kept growing. So we have plenty of devices spread out everywhere. And this allowed to concept and the definition of edge computing to become popular again. And people started talking about this again. And the point here is that edge computing walks side by side with a much more abstract concept, which is called ubiquitous computing, which basically means the ability to have any device, any format, anywhere at any time. So if you have spoken with anyone in the past, or if you even search online for edge computing, you might find several interpretations and many different terms that are associated with edge computing. Sometimes it might get a bit fuzzy for you. You might not really understand whether all of these terms are relevant or not. In short, yes, they are. We'll try to touch each and every one of them in this presentation. But when we speak about big data, we speak about clouds, AI, 5G, all of this is somehow related with edge computing, and either as an extra piece of machinery that you can use, or as something that edge computing can enable. So let's get to the definition of edge computing. Again, we are trying to keep things very simple. So for us, and we think that for everyone, it should mean that edge computing is as simple as just placing computing and data management capabilities as close as you can to your data source. And in short, this means near data processing. And if you look at this graph here, this is taken from the Google Trends, and it basically represents the interest over time on the topic of edge computing online. Ever since 2014, even though the concept is quite old and there was some interest before that, there's a spike. There's a big steep curve there where people started realizing that edge computing can actually do more than it was doing at the time. And the reason for this is because people understood that nowadays data is gold. So data is actually really valuable. And there are a few examples of these. You can look at some of the data scandals that happened just 2 years ago that affected more than 2.5 billion users, and that ended up in millions of dollars in fines to the respective companies. This is just to show you that those companies understand that data can generate information, and information is super powerful. Therefore, people started harvesting data through whatever means they can. Now, the thing is that data is coming from everywhere. And there are certain estimations, one of them is quoted here, that in 5 years from now, we will be handling around 40 billion IoT devices that are interconnected, that will generate more or less 80 zettabytes of data. Now, just to give you a quick idea of how much data this is, 80 zettabytes of data would be the same thing as if you would just binge watch 3.5 billion years of YouTube videos in a row. That's a lot of data. And contrary to what some people believe, data is not often born at the cloud. Data is born everywhere. It comes from us as humans. It comes from our interactions with equipment, from our machinery and the things that we automate. It comes from sensors. It basically comes from everywhere. We can find data everywhere. So most of the times, data is not born at the cloud. And this is very important to understand. So it is born at the edge of the network. And if we have 80 zettabytes of data, then we can think of doing something with it, because let's just face it, I mean, data without a purpose is just rubbish. You cannot do anything with data. It's just ones and zeros. And if you don't know what you are looking at, it's meaningless. So probably your first intuition would be, let's just process everything at the cloud, right? Let's just send everything, all the data that we have at the cloud. We deploy our applications and our algorithms in the cloud to process all of that data. Now, if you recall, 80 zettabytes of data is a lot of data. So we ask ourselves 3 questions every time we think about pushing data to the cloud. First, what about cost, right? If you are pushing that much data to the cloud, you might as well have a very strong and reliable physical network. And this is costly, right? Even with 5G that is coming now, 5G is quite costly as well. So whenever you are sending data to the cloud, you have to consider all of these aspects, plus whether your cloud service provider is even probably charging you for the incoming network. Another point is latency and reliability. So if you are dealing with critical applications, for example, let's say you have an autonomous car and you have one of the new fancy cars that is able to detect collisions in advance. As you can imagine, you cannot send the raw data to the cloud, wait for your application in the cloud to detect whether there is an obstacle in the road, to send you back the output so that you know, your car knows whether to stop or not. By that time, you already had an accident. So some applications are not meant to be run far from the source of data. And finally, there's privacy, which sometimes people neglect a bit because it's, well, it's not often spoken, but now with the introduction of GDPR, this issue became much more sensitive. And if you think about it, as an example, you might have CCTV cameras on a highway, and this is data that you can process to infer statistics of the traffic, to infer whether there is an accident, weather conditions. So if you would send all of your CCTV video data to the cloud, which some do and might be plausible in some cases, what if there's a man-in-the-middle attack? What if there's an intrusion to your physical network layer and people simply grab that video data and get access to your car plates, to your face, your identity? This is a big no-no from the start. Your edge application, your use case will be stopped, and there's simply no arguing that this is a good scenario. So these are things, these are three main key points that we usually consider when we are trying to build a use case and trying to decide whether we should use edge or cloud or both. So when we start thinking about edge then, whether our use case is suitable for edge or not, there's a fun fact is that because what I said before that edge is actually everywhere, and is quite an old concept, you can start thinking about cars, for example. Your average car nowadays already comes equipped with CPUs and even GPUs. Smartphones are another example, right? You have your voice assistant on your phone. Also, you have some local computing power in your phone to do all of your Face ID unlock and your fingerprint recognition. And there are 3.5 billion smartphones in the world. So that's a lot of computing power. And finally, another thing is that nowadays, with all the computing evolution over the past few years, we can find very capable computers, single board computers that are capable of running fully functional operating systems and quite some heavy workloads for as little as $5, right? So with this being said, it's time that we introduce edge computing into this architecture, right? We have that much data at some point, right? Why not just take all of those resources that we have or even add a few more and place them very close to where data is coming from, close to your sensors, close to your source of data. And here, you might be talking about edge servers. Some people talk about edge devices. Some people distinguish them. In our case, I'll just keep it simple. An edge device is an edge device that is sitting either at the edge of your network and connected to your sensors, or directly embedded into your hardware, like a car or any other smart sensor for the industry, for like robots. Taking a look at some of the other predictions for edge computing, like the ones that are usually sent out every year by Gartner, we have this graph here, which probably you guys are familiar with, which is called the hype cycle. Every year we have one. And this one here is, the topic is emerging technologies. It was launched last year, and the prediction was that everything which is edge AI, edge analytics, and 5G related, this is in the peak of inflation, which means that it's something which is becoming super popular at the moment, edge computing, because people understood that with so much data is not feasible at all times to send it to the cloud. Therefore, we just move the computing closer to the source. And some estimations even say that edge computing will be worth billions in 5 years. So it's quite a big market to explore. And when we think about it and we start to employ edge computing, we have to think about this concept that I've mentioned at the beginning, this ubiquitous computing, or UbiComp. Basically, it's any device, any format, anywhere, which means we have to start handling device heterogeneity. We will have all sorts of computing power. We'll have all sorts of devices that can process our data. And we can only build platform-specific software, right? We cannot build applications and algorithms that are supposed to run on specific hardware or specific operating systems. So for this reason, the usual excuse of, hi, it works on my machine, therefore it works in general, this is not applicable anymore. Because when we work with edge, we are working also with heterogeneity plus ephemeral devices, because at the edge, devices might come and go depending when you are dealing with mobile use cases or not, or battery-powered use cases. You might not always have a reliable connectivity to the wide area network. Therefore, your workloads must be able to run within a closed circle at the edge. Then we also have portability, because if your devices are ephemeral, then you need to be able to port your data and applications someplace else and still continue as if nothing happened. We might be handling limited computational power, because even though you can buy a fully functional computer for $5, it's not like you can run very, very powerful algorithms there. So we need to be able to cope with that. And finally, we have exposed environments. And when I mean exposed, is not, it doesn't mean that you are exposed to the wider network, but instead you are exposed to probably physical intrusions, right? So we want to isolate our data and isolate our applications as much as possible. And for all of these reasons, the community found out, and we also agree, and we employ these in our daily business at SixSq, that Docker can be used as a silver bullet here. So Docker will allow us to address all of these issues and try to tackle them. And again, if we check Google one more time, we can see that we were not the only ones to think this way. Actually, Docker, Kubernetes, microservices, everything container-based has been also growing in popularity since 2015, and it keeps growing every year. And some estimations even say that by 2020, which means this year, containers will be a $2.7 billion market. So with this said, since the container adoption has been steadily increasing since 2015 for 5 years now, and we think it will keep going that way, also because there are key players that are driving the maturity of the technology that we use for containers, like Red Hat, Google, and Docker itself. There are many companies that have joined this container movement, right? They are now starting to offer container management and edge management services, and SixSq is one of those. And if you haven't heard about SixSq, basically we are a small Swiss company based in Geneva, very close to CERN. We have representation in 3 different continents, and we are expanding. And in short, we like to call ourselves as software artisans of scale, right? We are experts in the unification of cloud and edge computing. What this means is that we try to offer products and services to our customers and partners in order to facilitate the deployment at the cloud, at the edge of any kind of service, right? So remember the near data processing plus the ability to offload your computational power and data to the cloud. This is what we try to offer and try to achieve a successful marriage between cloud and edge so that users do not need to worry about location or where your applications are running. We have solutions that we are providing for smart cities, big science, IoT, healthcare, and many others that are all either using cloud or edge or both through the products that we offer. And these products are mainly 2. First, we have Nuvla. And if you don't know, Nuvla just means cloud in one of the official Swiss languages. And basically, Nuvla is a secure edge to cloud management platform. In short, it's a service that you can use that will allow you to manage your cloud and edge infrastructures, plus manage all of your applications, deploy them, and also manage data. So it's a sort of near data AI enabler. I have an architecture picture here. I don't want you to get to go too in depth here because you don't need to read it all. But basically, on the top we have Nuvla as the first red layer. It offers all sorts of capabilities in terms of management for our applications, monitoring, telemetry, infrastructure monitoring. But then we also have data management. We have this sort of data cataloging service that will allow you to tag data and tell your applications where data is sitting so that you can much easier to get access to it. We also have, of course, end-to-end security to make sure that whatever connections we establish with either the cloud or edge, they're all secured and there is no leak of privacy data or personal data. And finally, there's edge control, of course. That's one of the key points in our products, which is the ability to spin off new edge infrastructures and be able to manage them, monitor them from remotely. And if you check the bottom layer there, the point for you to understand is that even though Nouveau is this sort of one service fits all, whatever infrastructure you might have, be it at the public cloud, a private cloud, or even at the edge, your laptop, your Raspberry Pi, your mini computer, doesn't matter. As long as there is a container as a service endpoint on top of your devices, be it Docker, Swarm, or Kubernetes, we can plug those into Nouveau and start managing those, right? So as you see on the right bottom corner, we include at the edge something called NuvlaBox, right? Which is another kind of edge device. And this is our second offering, our second product, which is basically another software stack, which provides the ability to transform any Docker capable device into an edge device. It's basically a solution in a box. Because let's face it, if you now decide to buy 5,000, let's say, Raspberry Pis or 5,000 computers, and that does not make you ready to start doing edge computing. You still need something else, right? You still need to set it up, you need to secure it, put some monitoring, or do plenty of things to make sure that your edge is stable, right? This is what the Nouveau Box is for. When you install a Nouveau Box, it's a sort of one-click installation that will transform your edge device into something that we can see from Nouveau and manage from Nouveau, start deploying apps from Nouveau, and is also capable of providing monitoring, security features, and all that. Again, we have its architecture here. Let's not go again into detail, but the point is that some of the features that the Nouveau Box offers includes, again, the telemetry, monitoring, automatic activation with Nouvla, and secure connections through VPN servers. We have security features to try to detect whether your box is being tampered with or being hacked in some cases. We also have mechanisms for handling data from sensors, like discovering sensors that you might have attached to your edge device, to your NuvlaBox, and allowing you access to all the raw data that is coming from those edge devices. So in a nutshell, we know that data is gold, but information is king. And this is what we do at SixSq. Basically, we enable the transformation of raw data into information, and that's really important. And we do so by allowing you to deploy your applications, your AI, anywhere, anytime, and without any privacy intrusion. Okay, so this is basically the end of the presentation. Now we have a short demo. So for the demo, I will ask you very quickly to make note of my video feed in your right corner of your screen. You should see a table, and there is a Raspberry Pi in there with a camera attached to it. Okay? So what we are going to do now is to assume a use case. And I have a simple architecture here. Let's just assume that this Raspberry Pi that you can see on the screen is sitting in some sort of control room, either at your place or in a factory, at your workplace. Is a control room, and there's a camera attached to it, a webcam. So what you want to do is that you have an application that you have built yourself that is detecting motion in that room, because it's a very sensitive room. You want to be warned every time someone moves in there. So you want to deploy something there, that's clear. But then you also want to be notified, right? So what we are going to do is that we are going to secure it through a VPN connection, because the Nouveau Box has set it up for us. We'll deploy an algorithm that will perform the sensor motion detection, and it will push notifications to another application that is sitting at the cloud that we will deploy as well from Nouveau. And then with our phones, we'll connect to this cloud broker and get messages in real time every time someone moves in your control room. So you don't need to be on the same side as your Nouveau Box in this case. You don't need to send all the video feed to the cloud. It's being processed at the edge. And this is to demonstrate all the architectures and concepts that we have defined and showed during this presentation, okay? So now I'm gonna switch my screen here. So I'm gonna end this presentation, okay? So what you can see here on the screen is Nouveau. This is your Nouveau.io, is your application management platform. So I just log in here. Right? So your first impression of the page is that you are given, and you can see it on the left side, many different sections. This will allow you to manage different things, from applications, from your edge, from different infrastructures. And you can see that I have a dashboard here, and there's nothing running for now for the sake of the demo. It's completely empty. I don't have any applications running. And if we go to the Edge tab on the left, you will see that I have one NuvlaBox. This is the NuvlaBox that you can see on my camera, okay, on the top right corner. So this is just a Raspberry Pi. I've installed a NuvlaBox there in advance before this presentation. But the NuvlaBox is simply a stack of containers, so it can be deployed at any time. It's quite easy. In fact, if you go to this page in Nouvla and you click Add, you just select a name for your NuvlaBox, and then you create, and you are given a compose file that you can just install in your devices. So I've done that for the Raspberry Pi, and you can see that is online. So it's plugged in, power is on, and there's a camera. If you click on the NuvlaBox, you can see some monitoring data, and you can also see on the bottom here the list of peripherals that are attached to the camera. One of them is the webcam. Okay, it will tell you what is the device that you can use if you want to get access to it, and other information about the vendor and model. Okay, so we know there's a webcam there. If we plug another one, the NuvlaBox will detect it automatically for us and push that information to Nuvla. So we would get automatically a new entry here if we put another sensor or peripheral into that Raspberry Pi. For now, let's just use one. So according to this architecture, the first thing that we want to do is to deploy an application to the cloud that will be our message broker. That will be the thing that is sitting in the cloud, waiting for messages to be pushed from, in this case, the edge from the Raspberry Pi. And then we will connect and subscribe to it with our phones to get these messages. Okay. So let's go to the App Store first. This is your App Store. This is how it looks like in Nuvla. You will see that by default, you will have plenty of apps that have been built and made public for you. Let's find an MQTT broker. All right, let's choose this second one here. Okay. Just click launch. And you will be given a set of possible infrastructures that you can deploy to. Myself, I want to use a cloud. So I'll select this fourth entry here, which is Exascale. This is a Swiss cloud. And I could define some environment variables. I don't need to. I don't have any for this application. So all I want is to deploy a message broker to Exascale, which is a cloud. So let's go launch. Okay. You will see that Nuvla will start contacting our cloud infrastructure and deploying this containerized service in there. Everything that we are deploying here are containerized services. These are all containerized applications. And if we look a bit more in depth into this message broker, you will see that we are simply using this Docker image. This is a RabbitMQ Docker image tag 1.0. And we are simply telling our cloud infrastructure to run this and publish the service port, the RabbitMQ port, into this external port. So this means that I can reach from outside the cloud, from outside anywhere publicly. I'll be able to reach my VM where this container is running through this port. Okay. So let's go back to our dashboard. Okay. Usually, an app might take a couple of minutes, depending on whether you have the Docker image already cached into your infrastructure or not. And once we can look at the output parameters here, we have all sorts of information. Once the number of containers running in the infrastructure matches the number of containers that you ask for, so once we have 1, we will have a green button appearing here with a URL for your endpoint. And there we go. Okay, so now we have a URL here, and you can see the full descriptive path in the bottom. Basically, swarm.nuvla.io 30303. This is the endpoint that I can either subscribe to or publish messages to send MQTT notifications. Okay. So that's pretty much it. Let's copy this. I will copy this endpoint, because what we want to do now, let's refresh our memory, is to launch a second app, this time to the edge, to the NuvlaBox, that will do the motion detection. And whenever there's motion, it will send a notification to this message broker sitting at the cloud. Okay, so let's go to the App Store again. This time I want a motion detector. Let's take the first one here. Let's click launch. Okay, and this time I will select the NuvlaBox, my demo NuvlaBox. Here it goes. And I will also pass as an environment variable the URL for my broker. Okay, so swarm.nuvla.io 30303. Okay, and I don't have any files. I could also pass some secret files or configuration files, but I don't need for this application. This is an off-the-shelf application we took from some open source code, and there's not much to it. Let's just launch. So once the application is deployed at the edge, you will start, again, the same thing that we got for the message broker. We will also get another endpoint that we can reach out to. But this time, because the NuvlaBox is sitting at the edge, this is a Raspberry Pi that you see in the image, let's assume it's in your control room, therefore it's under a private network. We are speaking with it through a VPN IP. And this is the IP that will be given to us once the application is running. Now, this motion detector application might take a bit more time, because if we look at the definition here in Nuvla, this is a more complex application with a couple of services running. So it might take a bit longer. What I said that we can do in the meantime is that I will show you on the screen here. This is my phone. I hope you can see it here on the right side. A pair of eyes. So I'll just open, I have an MQTT client here. Okay, while we wait for the Edge application to be ready, which is now, it's already there. You can see motion detector, now it's green. Nevertheless, my phone here has the MQTT client installed. I have all the parameters already set in there. Okay, so port 30303, I have guest, and connect. You can see connected. There's nothing happening yet, okay? But now if I click on this button here, let's click on this button, it will send me to a private, not private, the VPN IP. You can see this is not a public IP. I'm going through a VPN to reach out to the camera that is running at the edge in the Raspberry Pi. And let's bring back my my phone. Someone will pass in front of the camera, and when this happens, motion will be triggered, and we will see, there we go, there's already some shadows there, and someone passed, and we can see all the messages here on my phone. Motion detected. Now it stopped because there's nothing happening anymore, right? And let's recall again what's happening here is that my Raspberry Pi saw that someone was moving. The AI algorithm detected that and sent a notification to the message broker in the cloud. And we are connected to the message broker with our phones. So we got a message for every motion that was detected. It's quite a simple application, but again, here at SixSq, we are not developing end user applications. We develop the ecosystem and the platform that will allow you to deploy this kind of applications, right? This is just for the demonstration. So I hope you understood what was going on. Maybe I can just pass there again. There you go, a few more messages. And so this is part of the deployment demonstration. One other thing we can do with Nuvla is that, let's now say that because we are working with a customer or a partner that has a well-established DevOps workflow, we also provide the capability to do continuous deployment, either at the edge or at the cloud, okay? So what we can do is just go back to the dashboard here, right? Let's check my message broker app. If you remember, message broker, we are using a Docker image that is called SixSq tag 1.0, okay? So let's say what happens now if our users decide that, well, I have released a new version of RabbitMQ, okay? And you can see in my environment here, I have a version called 1.1. Okay? So let's push this to Docker Hub. It's basically the same thing as releasing a new version of your software. So let's say I have a new implementation of my message broker. And what will happen is that in Nuvla, we'll have mechanisms that are frequently checking for updates to your software, both the software that you have defined as applications and the deployments that are ongoing and being executed either at the cloud or at the edge. And this is a really cool thing, because this means that we'll give you the ability to update your ongoing deployments on the fly without having to stop them and restart them again, right? So if we go back to Nuvla, and we go back to the dashboard, usually these are mechanisms that run on a periodic basis. We are not trying to flood the network with these requests, but it's quite fast, and we can see already have one notification up there. And if we look at it, basically this is saying, hey, you have a component that is called message broker that can be updated. This means that if I click on it, this means that if I would update this component, all the new deployments that I would launch would have this new image. Let's just say I don't want this. Let's defer this notification. What will also happen is that I will also get notifications for any other component that is using this message broker, and also the deployments that are currently running. Okay, so there we go. New image is available for deployment message broker. Let's click on it. Okay, and I can just say apply. So I want to apply, I want to update my ongoing deployment. Okay, and if I go to message broker here, let's see what happens. At first sight, everything is the same, but if I look here, events and logs, let's put the logs running here. Events, 10 minutes after we did the first deployment, we restarted our deployment at the cloud, the RabbitMQ. And the logs, if we check the logs here, let's pause this. If we go up in Nouveau and check the logs, because we have access to all the logs that your applications are producing, we can stream them live. If we check up here, at minute 42, don't mind the hour because it's just a different time zone. At minute 42, we stopped whatever was working, whatever was there before, the previous instance of RabbitMQ. And there you go, stopping application, halting. And then if we restart this, we will see the new instance being, there you go, server startup complete. There's a new instance of RabbitMQ now running with a new version. Okay, and that's pretty much it for continuous deployment. We can automate this process so that you don't have to click apply. You can say just, I want to apply this for every time there's a new release, and therefore you have continuous deployments at the edge, at the cloud, doesn't matter the infrastructure. So as one last thing, of course, you can stop your application. So let's stop our, for example, our edge application in the Raspberry Pi. Okay, and let's also stop our message broker for the sake of it. And these are trivial operations. If you check then here, if you try to re-access your previous web feed, you see that it's no longer there. Your application has been shut down. You could redeploy it, that's fine. And if we go to Edge, same thing. If I unplug, and I will do it. I will unplug the Raspberry Pi, which is my NuvlaBox, and after a few seconds, whenever the heartbeat is missed from the NuvlaBox, because Nuvla is waiting for these heartbeats, we will realize that the NuvlaBox is down and can no longer be used. You can no longer deploy apps to it until it's back online again. And that completes the demo. Thank you.